All right, good morning. Good morning to all of you. Welcome to the Data and Tech stage at GreenTech 2025. My name is Jim van Ruijven. I'm a team lead at Wageningen University Research with a team of researchers focusing on everything that happens around the roots of plants. So the team is called Root Zone Dynamics. And today we will talk about autonomous water quality management. What is it? Is it already here right now, or is it a dream for the far future? So that's the topic that we will touch today. There will be plenty of opportunities to ask questions, and we will have some public interaction also at the end. So first I will shortly introduce the topic to you, and then we will have two speakers talking about the specific case of autonomous water quality management. So this global situation for water, world population tripled, so we need to be producing a lot more food. At the same time, good quality water is decreasing in availability, so we need to improve also on that. So increasing productivity twice, so twice the amount of produce with half the input of, for example, water. So that's what we're discussing today. I think you all know a figure sort of like this. So when you grow outside, you need quite a lot of water to produce 1 kilo of tomatoes. So when you do this in an open field with drip irrigation, you need more or less 60 liters per kilogram of tomatoes. And when you move forward to more closed and more controlled environment greenhouses, you can go in the end as low as 4 liters of water per kilogram of tomatoes. When you grow in a completely closed environment with also with dehumidification active and regain of water there. However, that of course comes at a cost of production factors. The control of these production factors will be better, but it also costs more money. You need more machines, more equipment, and more knowledge also to deal with all these parameters that are interfering with each other. So when we talk about water quality in closed cultivation systems, of course, you try to optimize your system to produce as much high quality product as possible. You need some inputs there, so you need your growing medium, you need water, you need fertilizers. There's also some passive input, things that you as a grower maybe don't want in your system, like root exudates coming from the crop, also pathogens entering your system, and you need to counteract them with application of pesticides or with disinfection products. And of course, then you can have some active output. You can do some actions to get rid of some elements that you don't want in your water. So you can discharge part of your water or not recirculate at all. Or you can apply technology to selectively or either disinfect or remove elements from this water. And of course, you want to have some water quality parameters. You want to start to control them because they will influence how your crop will grow, how your crop will evolve. And only for some we have currently some sensors available, and we know what the effect is on the crop. But there's many parameters out there that have an effect on the crop, and that we want to know the effect of for cultivation. So today we will be talking about mainly about the nutrient part. So I've got two speakers here, which I will introduce shortly. But all these other elements that you see here on the screen that can be interesting for future research and for future applications of water sensors, water technology to come to even more improved water quality management in your greenhouse, optimization of your production process. So I would now first like to introduce Tommaso Barbagli, researcher at Wageningen University Research on crop fertigation, and he will talk on one specific element of this autonomous water quality management, mainly fertigation, autonomous fertigation. So Tommaso, can I invite you to do your part? Yes, it works. Yeah, the clicker, sorry. Yeah, that's forward.
All right. So, nice to talk to you. First I want to show a very basic scheme of what are the main water components of a greenhouse system, and that what we need to automate. So in blue you see all the possible water connection, so from water collection to supply of nutrient solution and also recirculation of drain water. And when we look at which parameters we can control from the, let's say, climate computers, or in general how we can control the plants, from the daily supply tank, we can control frequency of irrigation. We can control start and stop, so the first cycle and the last cycle. And for each irrigation cycle, we can control the duration. And when we look into the mixing unit, what we can control is, of course, EC set point, pH set point, and as well as all the nutrients. So we can set the recipe for the plants, and most of the mixing unit can also control the amount of drain water that is reused. And then when we look at what is already available in a greenhouse, we have already quite a lot of sensors. So this is not new. In most of the high-tech greenhouses, all the sensors are already there. And of course, in a conventional system, you have the climate computer, which can already take some decision based on this data. For instance, shot of irrigations is already controlled by parameters like radiation zone. But also you have the growers that, based on each specific situation, like his crop or the crop stage, is also making some manual adjustments to the variable that I mentioned before. And when we think of what is autonomous fertigation, well, our answer would be basically we need to assist the growers with just a computer that in principle can already take all these decisions based on the sensor that we already have. So we don't need to reinvent the wheels, but the data are already there. But how to take this decision together with the growers or completely autonomously. So when we look at some sensors, I want to give an overview. There are multiple companies. If you walk around today, there are several companies offering different sensors. I'm just placing some examples. So for the root zone, water content, weight of the slab, so everything that is giving you information about the water status in the slabs. We already have some companies that can already automate the irrigation part. So some example are Source or Blue Radix. They already offer some of this autonomous irrigation. So they can control the start and stop, they can control the frequency, they can control the C set points, but they don't control yet the nutrients. And of course, another big bottleneck is that to get information on the nutrients composition of your solutions, the most common practice is still to take samples. And that's, for instance, laboratories like Eurofins, they can already do this, and then they can send the data to the growers. But there is no direct link between the data and a decision on how to change fertilization strategy. And there are coming up now new companies which can provide online measuring of the composition of nutrients. So we see that ion-specific technology is getting more and more into the market. And thanks to this type of sensor, we can finally link the final missing gap, which is directly steering also the two last components of this system, which is the recipe and also, for instance, a pH set point. And yeah, I'm very glad to announce today that we finally started a new project 2 months ago. It's called Alferti. It's a consortium. Well, this is the consortium, so I'm very proud that we managed to bring together all these important players in the market, and we will try to bridge this missing gap between what is already available and what really needs to be implemented. It's a 3 years project, and our goal is already next year to do the first test in an experimental greenhouse where all these components, which are mostly already there in the market, they are all integrated, they talk all to each other, and they take immediately decision on the fertigation strategy. So not only irrigation, but also nutrients, so also how to steer with your recipes.
All right. Well, before we go to questions to the audience, question from me to you: what would be the ultimate result, the most ideal result coming out of this Auverti project? When would you be, well, over the moon if that happens?
Yeah, well, for me, but I think also with all the partners, what we see is that at the moment it was really missing, let's say, a connection between these companies. As I said, they are already there. So I would be very happy in the moment that really in 2026 or 27, the companies already going outside with this solution for the growers. So besides the research part, it's really more, okay, this is needed. We see that there is a big demand from the growers. So in the moment that all these companies partner together and they reach this autonomous fertigation in the next 2 years, then yeah, I would be quite happy with that.
Nice, then you will be over the moon. Great. All right, any questions to Tommaso from the audience? If not, then we will move on to our next speaker, Sean van der Wilk from GreenV. And he will talk about the practical application side of this autonomous fertigation or autonomous water quality management when we talk a bit broader than that.
Ja. Staat hij aan? Ja.
Ja.
Oké. Mooi. So, Tommaso, thank you very much for the introduction. I think what I would like to do is today talk about the practical implementation of what is just discussed. So, let's say to start, let's say, with a centralized data platform. I think, Tommaso, what will happen? You will see we have sensors. There will be climate data. There are data platforms as discussed. And finally, let's say from all this information, there will be automated analysis and recipes available for your installations. But how to implement that, let's say, into your system, that is what I'm going to talk about. In the end, the output will be to the climate systems and to the irrigation management systems. So that's the practical implementation. And today I'm going to talk about how can we implement this. So what you will see, finally there will be from all the data that is collected, from every thing that is analyzed, you will get an adjustment on your fertilizer strategy. Today's case is, let's say, that you get 1 or twice a week, or maybe once every week or 2 weeks, you make a recipe analysis and you will change your A and B stockings. And based on that, let's say, you will have fertilizers for your crop for that week. What we are aiming for, let's say, is to do it much more frequently and be able to adjust on the fly. Let's say much more according to what the needs of the crop is, instead of, let's say, do it once a week. And there are, let's say, 3 adjustments that you can do, and I'm going to talk about, let's say, automatic filling of your A and B stock tanks. I'm going to talk about how you can adapt it to the irrigation units as you have them today in your industry. And the last one is that we can also do it with liquid fertilizers and change, let's say, your recipes with liquid fertilizers. So this is actually the whole water chain. So this is the complete water management. And as Tommaso already explained, there will be sensor technology available that we will put in the mainstream of the irrigation into the greenhouse, and there will be, let's say, a sensor that's in the drain, return, and based upon these measurements, we will know, let's say, what did send to the crop, and what is actually coming back, and what the crop did take. That's the analysis. Based upon the analysis, there will be, let's say, a fertilizer strategy for the customer which is available. If you see over here, liquid fertilizers, automatic A and B stock tank filling, and these are the A and B tanks that you might have available at your facility. What we can do is, with this adjustment, we will bring it, let's say, the software will, we will bring it, let's say, into our system. The computer will automatically fill your A and B stock tanks based upon the recipe that is available from the technology, the sensors, the data. And with this system, it's now, let's say, once a week you have to do that by yourself. With this system, you are able to do that fully automated. That is one. Sorry. So these are a few of these examples. They are, let's say, these installations are today available. As you can see over here, you see installations, let's say, the A and B tanks are here, the fertilizer tanks are, let's say, completely filled automated. But this is still a manual action, what you have to do, let's say, as a grower. You still have to make your own recipes. And with the new technology, we're aiming to do that automated and more frequently. So these are a few examples which we've already built into the industry. So the technology is already there. If we have the analysis, it's just click it onto our process system and it will work. The next one is to talk about, let's say, your current irrigation system. Today you see irrigation systems, let's say, that have an A and B tank, and you're filling the A and B tank, and if it's empty, you're going to fill it the next day or the next week. What might be the future, that you've got, let's say, multiple A and B tanks connected to one irrigation unit. And then based upon, let's say, the analysis, the software that is behind, it could measure, let's say, that in the morning it might have other needs based upon light levels, about everything. So in the morning you, let's say, would like to irrigate, let's say, with A and B stock tank 1. In the afternoon, the computer could manage, let's say, to use A and B tank 2. And in the evening, it could, let's say, be well possible that you've got another recipe. This could even be done during the day based upon, let's say, the influence of the weather, light levels, all that, that is possible. And with this, you will have, let's say, your normal installation, your normal irrigation system, a bit more A and B tanks, and then with the automated recipes, you can just be very flexible in your irrigation, and then you will have more precise dosing cycle as you do today. These are a few of these installations, just as an example. So you will have a unit with more, let's say, A and B selection valves, and the computer, the process computer, will automatically, let's say, connect it to the data platform. The data platform will tell you which A and B tank, and the computer will do the rest. This is also one installation. So as I mentioned, the installations are already there. It's purely, let's say, to add on the software which we're developing at the moment. And then the last one, that's actually mainly, I think, used now in the Netherlands, because liquid fertilizer is not everywhere in the world available. But what we can do over here, let's say, if you have liquid fertilizers, there are installations that take the liquid fertilizer and inject it directly, let's say, into the mainstream or in a day storage tank. And with this system, you could, let's say, have a fertilizer strategy that is, it's actually almost real-time online. It can just measure the elements, change the elements on the fly. This is for now for the Netherlands, because liquid fertilizer is not available everywhere in the world. So this is an installation. Actually, this installation we just installed at one of the customers that has a lot of different recipes. It's an R&D facility, and they want to be very flexible with their recipes during the day. They've got 26 zones with all different crops. And this system can just do all the recipes online on the fly. And how beautiful is it if we have sensor technology and data technology combined together to adjust these type of systems. So these are just 3 practical implementations Of course, we're still doing a lot of work together, so we're not there yet. But I think for the future, this is an optimization of the fertigation. That's the goal we have, because you said the world population will increase, and we need to be more focused on saving water, saving fertilizer, and doing the right thing with the fertilizers. So that's my part of the story.
Okay. Thank you, John. Are there any questions from the audience to John? Yes, I'll come to you.
Hello. Thank you very much. Fascinating talk from both of you. First, a question for you. When you say that there is no liquid fertilizer available in other countries, you mean the product which comes from the manufacturer as a liquid fertilizer, or the ones which are solid and we dissolve it in water and it becomes a liquid fertilizer?
Actually, yes. Today here, let's say, there are, let's say, from the factory straight, let's say, to the growers, they will have liquid fertilizer. So there will be trucks coming with liquid fertilizer, and they just fill up, let's say, automatically the fertilizer tanks. But I agree with you, let's say, if you can have solid fertilizers, which you will make them, let's say, liquid, it's a bit more work. But then, let's say, you could do the same. But for now, we do see only in the Netherlands, maybe a little bit outside of the Netherlands, maybe Belgium, Germany. But if it goes further, it's normally always solid. Yeah.
Thank you. A question for Thomas. Thomas, it's a fascinating project, and it's well done to you who have managed to gather all these leading companies together. My question is that how do you manage their expectation, their competitors? They might have their own agenda, so how do you manage to work with them? And when the outcome comes, how do you manage to share it within the group?
Yeah, so within the consortium itself, I think all companies are quite open, because what we see, they are motivated to reach the same goal. Of course, IP of every single company that is protected. Yeah. So what we can do as, let's say, independent research institute is that we use the output of all their IPs. We try to combine it together in a kind of a prototype central brain that takes this decision. And I think what we can offer to these companies is that at least, let's say, together we decide which can be the best route. And we just have meetings together, and we decide which is the best combination, the best way to proceed. But it's also a lot of trying and fail. And,
it's a learning curve.
Exactly. And it's good that we do it, because then it's not a grower that is risking the crop, and we can risk the crop.
Okay, but the outcome definitely will be shared between all these companies.
So the project, it's a public-private project.
Okay.
So at the end of the project, it will be published. Okay. Mostly what we do in this project is, let's say, the advantage of being in the consortium is that you have immediately the knowledge and the experience from the project itself. And at the end, of course, it will be published. That's...
Just one last question. Who is the funding body?
The public part is the Dutch government.
Dutch government. Yeah. Okay. Thank you.
Yeah, thank you. Any other questions from the audience?
Thank you. So I have a question about this interesting system. And when the collection of the drain water for the water analysis comes, is it automatically analyzed before getting back to the supply for the change of the recipe, or you still need manual sampling?
Well, what I can answer, let's say the sensor itself will measure. It goes into the data platform, and in the data platform, let's say, with all the data which is available, there will be, that is the goal, finally an automated, let's say, recipe strategy coming into the equipment. So there should not be any manual interaction unless we put it, let's say, that you say as a customer, I still want to have the final check, and then you could, let's say, give it as an advice. But the goal is, and correct me if I'm wrong, Tommaso, is that it's fully automated without any manual interference.
Yeah. Okay.
Yeah.
Thanks.
All right. Any other questions? Otherwise, I have a question to you, John. So you're talking about changes to your way of analysis. You're talking about changes to your substrate unit.
Yeah.
What about changes to the rest of your system? If you want to have frequent changes of recipe, do you need any other changes in your whole cultivation system in order to, well, get the most benefit out of this?
I think it's always a combination of, let's say, sensor technology that measures, let's say, the evaporation of the crop. That's where it starts. So I think what is really important that you measure the evaporation of the crop, because that will give you the signal, okay, the weather is changing, so I need to irrigate. That's one. But let's say on the installations, for now there would be, of course, one thing would be important. You need to make an API, so there need to be connection, let's say, from let's say the cloud towards the process automation to make that happen. So there will be an involvement on software connection, but on the technology on the installations, it's not that complex, because it should be some more A and B tanks, some more A and B selection valves, but it's not, let's say, that it should be a total change. Unless you go to liquid fertilizer, then you need a completely new unit.
Sure.
But I think that existing installations can be adapted to the new technology.
Anything to add there, Tommaso?
Yeah, I think if you refer also to the fact that you have, let's say, a certain buffer of your nutrient solution into the system, something that we already know that is available, it's basically different irrigation lines that can work at high pressure and low pressure. And the idea is that instead of, let's say, that you have to go from your new nutrient solution to your drippers, that you can recirculate into, they call it a ring irrigation, so you can constantly flow the nutrient solution in this ring, and only when you go at high pressure then the water goes from the irrigation line to the drippers, and in this way you could be able potentially to change an entire buffer of water that you have in the greenhouse. What you only need are different silos to storage all these nutrient solutions.
Sure.
But potentially it's already possible. It's not used yet because there was not the needed to do it yet.
Yeah.
Maybe to add one thing to that, let's say, is you could, let's say, have multiple main lines. So you've got recipe 1, 2, and 3, and then based upon, let's say, indeed, let's say, the fertilizer choice, you will switch from main line 1 to 2 to 3. So then you don't have to do any flushing, and that's also an option. Otherwise, you always have the wrong recipe, let's say, in your main line for maybe the first 3 irrigation cycles.
Yeah.
So these things might have to be adapted, but it's doable.
Yeah. So actually what you say is by getting this more flexible way of creating your nutrient recipes, it also changes the way you need to organize your whole irrigation system in the greenhouse.
Correct, yeah. Yeah.
Lower the volumes, faster flow through or whatever is also needed. All right. I've also prepared some statements that I want to first ask to the two speakers and then also to the audience if you have an opinion on them. So the first one is autonomous water quality management is an important step forward for growers. Tommaso, what is your opinion on that?
Definitely. I think two factors. First of all, water quality is getting worse. So the growers need always to find a way to get a better to get to a better quality water. But also it's important because there are still a lot of unknown factors. You mentioned in one of your slides this root exudates. So what we know is that especially in a recirculation system, where you don't discharge any water from your system, so you keep going and going and going, potentially for years, the growers do experience problems. And also from a research perspective, there are still questions that we can't answer. We don't know the origin of these issues. It might be just a technical problem, but it can also be maybe a disease that we cannot measure it yet. So I know that, let's say, the industry is also very active in looking even for more sensor on how to spot these possible new diseases or how to measure these root exudates. And potentially, if we look to the future, it could be that if we have a sensor that can measure, I don't know, even the amount of a certain disease, and then you only do the disinfection for these diseases when you know that it's present.
Yeah.
So all this is optimization that potentially in the future could be applied.
Yeah. All right, John, anything to add?
Yeah, I think for me it's all about risk management. If you see, the grower should be focused on growing and not being focused, let's say, on let's say, these type of topics. You know, if I drive my car from A to B, I don't really care, let's say, how many cylinders it does what, but it has to bring me from A to B.
Yeah.
And the moment you can, let's say, eliminate, let's say, risk factors, because the human being, you know, we make mistakes, and the more you automate, the less mistakes you make, and then you can focus on the crop, and that's the main goal, and also for growers. So in general, I really admire, let's say, this route, let's say, towards more, let's say, automation that keeps the grower away from thinking about topics that he should not have all the focus for.
So it's for you, it's more like risk management than really improving your production process and getting more.
No, in the end, you will improve for sure your production process, because it will be optimized, let's say, under all conditions. If a grower doesn't pay attention, maybe because he's too busy with something else, then you might lose something on production. So for sure, it has all to do with increasing the production, but also, let's say, decreasing the water consumption and fertilizer. But I think also risk management, I mean, the grower should not be focused, let's say, mainly on this. It should do the work.
Yeah. All right. Anyone from the audience? Yes. See a finger, a raised hand here.
Yes, thank you for your elaboration, Tommaso and John. I had a question maybe more from a commercial perspective. So how does the business case work for this water quality management? Like, how much does it cost, and what would you save or increase in terms of product quality or whatever? Can you elaborate a little bit on that?
So that's a good question, because we're, of course, in the middle of the research. My vision on it is, let's say, that you finally will have, let's say, less fertilizer waste, because you're exactly giving the right fertilizer, and the business model will be that for the customer, he must increase his efficiency. He must increase, let's say, his production, because it all has to be related or to production or savings. It's one or the other. I think you can do both, and for us, the business model will be that we can, let's say, implement the technology needed to do so. But for the grower, it should be increase the yield, quality, and decrease, let's say, fertilizer cost. That's my take on it. I don't know, Tommaso.
Yeah, also what you mentioned before, risk management. In our consortium, we also have the insurance of the growers, and they are highly interested in this topic, because what we say is that, well, first of all, we have less people, less skilled people. So let's say also in agriculture in general, the amount of skilled people is going down, but the complexity is increasing and the food demand is increasing. And yeah, it's probably something that as a researcher I get the input from the industry, and they say we need this because the growers need this. And what you say, the growers would probably prefer to go in Spain for summer and just leave his greenhouse running completely autonomously, and he's totally fine with that. Now it's more building the, let's say, bulletproof situation.
Yeah. First.
So do I understand correctly that there should be a number of benefits from this system, but the promise that you make, so how maybe in percentage or in turnover or whatever, that still has to be decided in the project that you explained. Is that correct? Or?
Yeah, it's true. So actually, one of the work we still have to do is to decide the KPIs for this Auferti system. So what do we optimize? Do we optimize, let's say, production or quality? Or it can even be something else. It can be water use, nutrient use efficiency. We don't know yet. Yeah, that's true.
But I think honestly that how I do see it is, let's say, normally you take, let's say, your samples once a week, or once every 2 weeks, depending on the season. if you can do it much more during the day, then you always are more accurate, let's say, to give the right elements at the right time to the crop. We believe it must be an increase in quality and yield, because you're more, let's say, exactly irrigating what the crop just took, let's say, from the water, let's say, string. And but of course, that is why we are investing this, and the results have to be in this position.
It's a whole new world opening up, right? So we don't even know if it has an effect if you irrigate or fertigate differently in the morning than in the afternoon. Maybe there might be some extra benefits, but we still need to find out. And then we can decide on what is the big effect on yield and on productivity. Yeah. All right.
Thank you, Jim. It's not really a question, but a little bit of a addition on the questions that were asked. We produced the CE line sensor that is discussed, and we already have several of them in place worldwide, and we see that having the data on a daily basis just reduces risks big time. Yeah, because if you measure one time a week, as I said, you simply don't know what's happening in between the data points you get. So the proof on that is already there. Now it's very interesting to see how to automate that in the whole system of fertigation, of course. That's the 40 project, but the security part is already proven.
Thank you, Simon. All right, let's go to the second statement. So it says autonomous water quality management will be common practice in the next 5 years. John? What do you think?
I think within the next 5 years, for sure, I do believe so. And I have been surprised a few more times. I'm 40 years in the industry, and I always thought that will never happen, but it did. And I can, I'm busy with quite a few projects, and I've done quite a lot of projects in the world where I thought this cannot be feasible. But in the end, if you are a group together working on this, I think within 5 years, I for sure do believe that will be possible.
Yeah, for some of the parameters that we mentioned, right? So now we're talking about fertigation, but all these other elements.
There's still a lot to explore, but let's say the first steps for me, I already see it happening, because let's say connecting the API, connecting to the computer system, giving the analysis to the customer, that would be the first step. The second step would be it's automated, but I will see this happen,
Okay, Tommaso, anything to add there?
I agree. So I think for fertigation we are very close. So I hope in the next 2 years, water management in total, like maybe also autonomous disinfection, autonomous filtration, and maybe choices of which water source I use now. It's not, maybe that will take a little bit more time, maybe 5 years, maybe 10. I see that it all happens in phases of priority. So. But also if we get a drier and drier summer and worse and worse water quality in the well, maybe that will also arrive faster. So.
What knowledge would still be required to reach this? Not specifically for fertigation, but for other things. For sodium, you've been doing a lot of research, right, on threshold values.
What we still miss, it's a lot of knowledge on heavy metals. So we don't know yet exactly which are the thresholds of susceptibility for the plants. So we still use the let's say the limits from the food industry. So this is our assumption of the limits. Mm-hmm. But like for ornamentals, you don't have to eat flowers, so it might be that these limits can be different. And also this, let's say, water diseases or root exudates, there is still a lot of unknown work there.
Connected to plant health as well, right?
Yeah, maybe I can add to that. It's indeed, I'm busy with a few projects, and then we have the discussion about sodium. Should we take out all the sodium, or should it not be needed? Should we take out a portion of the sodium and combine it, let's say, with well water, which has a bit more sodium? So the level of sodium, let's say, for tomatoes, cucumbers, peppers, we hear a certain number, but we don't really know. And we also don't know, let's say, what does it to harm the crop, let's say, on which level it starts. So that's also something where we could optimize, let's say, to have your main water stream.
Yeah.
And that's also has to do with data that we still have to collect.
Yeah, and connect water treatment to it. So
Yeah.
if the levels rise too high, maybe selectively remove the sodium in this case.
Exactly, yeah. That's what we're looking for, but that's knowledge that we still are developing together.
Yeah.
Well, actually, I would say we do have the knowledge, but you see, when research failed to communicate to the industry.
Sometimes we do, yeah.
So probably that consortium was not that good as hopefully this one, because we already have these new thresholds, but they are not used yet. So
Yeah.
communication is also important.
Yeah. All right, thanks. Any comments from the audience or any thoughts on this statement? Any questions that you have on water quality management? What questions do you have in your company? What do you face with your customers in the industry? Anything from you? Do you see anything happening at the growers or at your own? Okay, yeah. So you're just friendly watching his presentation. Good. Moral support. All right. Then the final statement. Autonomous fertigation can increase productivity enormously. Tommaso, maybe a question first to you. What potential do you see in improving yield with this new technology?
Not enormously, but let's say what we calculated, it could be between 2 and 5%, at least in the Dutch context, where let's say you already have a lot of knowledge, a lot of experience, a good quality input, so it's already really maximized. Let's say
Even then you can reach 2 to 5% more production.
More. This is based on assumption of let's say how much we deviate from optimal nutrients levels close to the roots. But it's still difficult to measure it, because at least in research proving that it's a 2 or 5% difference, it's hard.
Statistically,
statistically it's hard. But we do know that it's enough for the growers to have interest, because for them already a 1%, 2% yield increase, it's millions.
Yeah. John, anything to say on that?
Yeah, I think, let's say, enormously, I also do not really believe. The point is, it depends on where you're aiming for. Let's say in the Netherlands, I think if we can do 2 to 5%, it would be fantastic. I think over the world, let's say, we might be able to get even more, because then if you're a little bit further away, it's more difficult to have your analyzers, let's say, on a daily basis, weekly basis. And if you can do that, it might be a big improvement also.
Yeah.
So depend on where you are in the world. But for sure, I see that we can increase the number. It will differ.
Yeah. All right. So I see that we still have 2 minutes left. So if there's any remaining questions from you to the speakers or to me, then please be welcome to address them.
I'm sorry if I'm taking up too much time.
No, that's
to
not
the rest
a
of the
problem.
audience. I just had a question. Of course, this is focusing on greenhouses, but water scarcity is a problem all around the world, also in different sectors. For instance, open fields or in orchards or whatever. I'm just curious if you are also looking into those different sectors to see if this system or part of this system or principles can be applied to different sectors in agriculture.
Yes, we do, for sure, and it's a very good question, because indeed we are also active in open field. We've got quite a lot of customers with strawberries, blueberries, and they use quite a lot of water. And we are also implementing, let's say, installations to improve, let's say, water quality, decrease the amount of water by doing it in a different way. So on open field we're also active, but it also depends on, let's say, if the customer is willing to invest in it. And what we see sometimes, let's say in parts of the USA, they rent, let's say, a land for 5 years and they don't want to invest too much. So they just do, let's say, sprinkler irrigation. Yeah, that's probably not really sustainable future-wise. But we've got customers where we did automate, let's say, 60 hectares with drip irrigation on blueberries and also make clean water with RO installations. So yes, we're focused on it for sure as a company.
So probably you need some different sensors there, because, well, your soil is a big buffer. You're not you're not recirculating your nutrient solution, so there the need for adaptation of your nutrient solution is less probably, or you need sensors that are measuring the nutrient composition in the soil instead of in the water, so to adapt it by applying the right fertigation in the end. So maybe it requires different sensors or an extraction technology to get these elements in the water and then analyze it again with the same machine. So that, yeah, the principle is the same, only maybe the sensors are a bit different. Yeah, I agree. Any last question before we finalize this session? All right, then I would like to thank you for your attention, and I would like to wish you a very pleasant further stay here at GreenTech. Thank you.